Sadi Carnot was a French engineer who was the first person in history to come up with a abstract theoretical model for heat engines that persists to this day. This picture here is basically Carnot's model of the heat engine. It depicts a hot temperature region, a cold temperature region, and the circle in between those two regions is the heat engine. There is a heat flow from the hot temperature region into the engine, and the engine uses that to produce work. And then there's a waste heat flow into the cooler region, which in reality generally represents the environment. And Carnot discovered that this was a necessary component of engines. It was already known in his time that to get a steam engine to work efficiently and to not like melt down or blow up, that this was a necessary component. But Carnot was the first person to realize that this was necessary for more than just practical reasons, for theoretical reasons as well. In this topic, we're looking at this picture and what is described by it as a model to help us understand what is and what is not a heat engine. So the key features are written over here on the whiteboard. A heat engine takes thermal energy at a high temperature and uses it to produce work. So that's two of the requirements. There must be a high temperature. There must be a heat flow that represents the thermal energy being taken into the engine. A heat engine also produces thermal energy at a lower temperature. So there must therefore be a heat flow into a lower temperature region in order for whatever device we're considering as a possible heat engine to actually be a heat engine. But that is the only requirement. So we'll see when we look at the examples that there's quite a range of possibilities, especially in the modern world, for devices and technology that fits within this general category of what we mean by heat engines.